what are we doing today? Well, we're going to be using corresponding parts of congruent figures to figure out missing pieces. How will we do this? We're going to identify which pieces are corresponding, recognize that they're the same measurement. Why are we doing this? Because transferring information from one figure to another is super powerful. If we've got something over here and it's a model for the thing on the right instead, well, we can transfer the information and actually solve the problem. So let's talk about what it means for figures to be congruent, not just angles and not just line segments to be congruent, but the whole figure. In order to be congruent, two figures have to have all their pieces that are corresponding congruent to each other. What do we mean by corresponding? So let's look at what we have right here. This ABCD is congruent to EFGH. All right, we've got these two four-sided figures. In order for this to be true, that these two figures are congruent to each other, angle A has to be congruent to angle E, because see how it's the first letter and the first letter? The orange one and the orange one? Angle B has to be congruent to angle F. Again, the second letter with the second letter. Angle C and angle G have to be congruent, the third letter and the third letter. And then D and H have to be congruent, the fourth letter and the fourth letter. Notice that's what I'm talking about right here. So the angles have to be congruent, but on top of that, so do the side pairs. And once again, if you look at the statement here, AB, the first letter and the second letter, EF, the first letter and the second letter, right? BC and FG, CD and GH, DA and HE. So what I'm going to tell you, what I'm going to tell you as you're doing problems about this, number one, if you don't have a picture, draw a picture, because drawing a picture is going to take this problem and make it 50,000 times easier. I promise it will. The second thing is look at the congruence statement that I've given you, or that the problem has given you, or whatever. Work off of that too. The pieces from one to the other should be the same. However you label your congruence statement, the pieces should be the same. Now, one thing about how you name a figure like this is you always start at one letter and then go around in a circle. You don't just sort of pick the letters randomly. Like I couldn't call this four-sided figure ACBD. If I start at A, I have to go clockwise and call it ABCD, or I have to go counterclockwise and call it ADCB. Now, once again, it doesn't matter where I start. It doesn't matter what letter I pick to be the first letter, as long as I, number one, am consistent, and number two, go clockwise or go counterclockwise around. I can't just sort of skip around. I have to specifically pick a letter. Like, let's say I started with G and I chose to go counterclockwise, then this figure would be called GHEF. And if I'm going to write the congruent statement, they have to match. G matches with C. H matches with D. E matches with A. And F matches with B. So as long as I'm consistent, and I specifically go around the outside in order, in either direction, it doesn't matter. I should be good with how I name things, okay? So just keep that in mind as you're going through. Keep that in mind as you're going through. All right, so let's go ahead and do some problems now. So look at what they're telling us. Hij is congruent to L, M, and O. So they're telling you H corresponds to L, I corresponds to M, J corresponds to N, and K corresponds to O. I want to know what are all the congruent corresponding parts. When they ask for this, if they talk about congruent corresponding parts, they're talking about angles and sides. So it might help you to actually list them out. Here are my angles. Here are my sides. Yeah. It doesn't, it doesn't matter if you do that or not, as long as you have all the congruent corresponding parts. And, this is a four-sided figure. So there's 1, 2, 3, 4 sides, 1, 2, 3, 4 angles. So in order to get all the points for this problem, there better be 4 pairs of sides, 4 pairs of angles, so 8 statements total. So let's start with the angles. We'll do H, we'll do I, we'll do angle J, we'll do angle K, and we will see that they are congruent. And, to be honest, especially when they're not like well ordered like this, I wouldn't necessarily trust the picture. That's just me though. I wouldn't necessarily trust the picture. I would say to myself, all right, well, I've got a picture, sure. I can sort of visually see what's going on to kind of help me, but I would trust this much more because it's actually telling you something. This maybe, maybe you misread it a little bit. I wouldn't trust a picture unless it is specifically said that it's to scale or it has some critical marks on it or something like that. So let's look at this. H is the first letter. So what's the first letter on the other one? It's L, right? So angle L goes here. I, well, that's the second letter. So what's the second letter over here? M. J, well, that's the third letter. So N. K, that's the fourth letter. So it's congruent to angle O. So here's all my 4 angle pairs. Now let's get my side pairs. So again, starting with, it starts with H. So let's start with H. HI. Side HI. IJ. And you can just go sort of around. Right? That's a bad arrow. There we go. IJ. And again, notice I'm putting a hat on top. JK. KL. Nope, there's no L. After K, I go to H, right? HI, IJ, JK, KH. Be careful. Sometimes you're going to run into just sort of your brain is going on autopilot. Avoid that whenever possible. So once again, let's look at our congruent statement up here. Let's trust this. HI goes with which LM, right? And how do I know that? Not because I'm looking over here, but because I'm looking. H and I are the first 2 letters. So what are the first 2 letters over here? L and M. 1, 2, 1, 2. And notice I'm specifically and purposely, deliberately putting them in order. I'm not doing HI and ML. I'm doing HI and LM. H goes with L. I goes with M. H, anywhere you see an H, you better see an L. Anywhere you see an I, you better see an M. Simple as that. IJ is the next one, 2 and 3. So 2 and 3 is M and N. And again, I'm not following the picture. I'm looking explicitly at this here. JK. Well, what's J? J is the third letter. K is the fourth letter. Third, fourth. NO. Last one, KH. Fourth letter, first letter. Fourth letter, first letter. OL. Yeah. So all I did is I listed them out. The angle pairs are these. The side pairs are these. 4 sides on the figure. There better be 8 congruent corresponding pairs of parts. Simple as that. If you don't have exactly this, I'm going to tell you right now, you're not going to be right. So I'm going to give you all 2 minutes. Same idea. Notice how many angles, how many sides there are going to be. Alrighty. So again, I'm not saying that you have to do this, but I am saying that sometimes a picture, even though we didn't like super use it here, does help to sort of direct our thoughts a little bit, you know? So, you go through 3 points, and also they give you the little triangle shape. They're telling you that these are triangles, right? When I draw these out, I like to set myself up for success and actually make them look corresponding as well. Now, the thing that I've drawn here, just 2 lumpy triangles. You're not expected to be an artist. I'm certainly not expecting you, because why would I expect more of you than I do of myself, right? I know that this is probably the best I'm going to do with these triangles. And so, that's fine. So WYS. So I always just start at the top, W, and, whatever I'm feeling like that day, but I'm going to go counterclockwise right now. WYS. Actually, maybe let me move this triangle over a little bit so that it's a little bit clearer. They're not squished together. So we got WYS, and I'm going to do the same thing in the exact same order, right? Started at the top, went counterclockwise. So I'm going to do the same thing here. M, K, V, just like that. And now I have a picture, and because I've drawn this picture specifically to scale for myself, and to make it corresponding, I can actually look at the picture and have it have meaning, whereas the last one we really couldn't. So here I'm going to do the same thing now. Angles and sides, right? So angle W, angle Y, angle S. Okay, so W, if you look here, W goes with M, the first letter, so angle M. Y goes with K, it's the second letter, angle K. S goes with V, the third letter, angle V. So there's my angles, and I expect there to be only 3 because it's a triangle. 3 angles, angle, right? 3 angles. Could have also called it a trilateral. Because there are also 3 sides. And I'll tell you, as we go through this chapter, we're going to spend a lot of time with triangles, because triangles have a lot to say, both within geometry and outside of geometry. But especially when we're talking about in geometry here, triangles have more stuff to do because there's only 3 sides and 3 angles. So a lot more things are forced to happen, which is nice. A lot more things that we can actually figure out. WY is our first side. Side WY. YS is our second side. And SW is our third side. And once again, if we look over here, WY, letter 1, letter 2. Letter 1, letter 2 is MK. YS, second, third letter. Second, third letter is KV. And then SW, third letter, first letter. Third letter, first letter here is VM. And once again, take the time to look here. Take the time to associate the letters with each other. If it's a W on one triangle, it's going to be an M on the other triangle. Anywhere you see a W on the left, on the right is an M. Anywhere you see a W on the left, on the right is an M. Anywhere you see a W on the left, on the right is an M. Same thing with the Y and the K. Same thing for the S and the V. Right? Each letter has a brother or sister on the other side, right? Each letter on the left triangle has a sibling that is identical on the right-hand side. Keep that in mind, and then you will never go wrong. Trust me on this. Okay, so take a look at this problem. So this is an SR-71 Blackbird. It's an aircraft of some kind. And what you notice is from left to right, we have symmetry. We have what one might call a, oh, but I want a dotted line. Give me a dotted line. There we go. We would refer to this as, I believe, bilateral symmetry, right? From left to right, if you folded over this green dotted line, you would see that everything lines up. So before we even begin, let's make note of that, and let's write our congruence statement here. Triangle ABC is going to be congruent to, well, look, we've got symmetry, right? So we're backwards. A lines up with D, right? B lines up with E. And C lines up with F. Now, a lot of the ones here so far have been, the letters are in alphabetical order. It doesn't have to be. I could have started with any letter I wanted. And as long as A matched with D, C matched with F, and B matched with E, I know I'm okay. So once again, what we need to be able to do is we need to be able to figure out angle D over here. But in order to figure out angle D, I need to know, because I don't have enough information over here, I need to know some other stuff, right? If I want angle D, I better be able to get that from angle A, right? Because angle D and angle A are congruent. That is to say, the measure of angle A is the same as the measure of angle D. So how do we figure out what angle A is? Well, don't these three angles of the triangle add up to a certain amount? Right? The measure of the three angles of the triangle always add up to 180. So A, B, and C, those three angles had better make 180. Angle A plus, well, what's angle B? It's 30 degrees, right? What's angle C? 75 degrees. The measurements thereof better make 180. So let's plug everything in. Let's use the substitution property. The measure of angle A is what we're looking for, so we can get angle D. Plus the measure of angle B, which is, they tell us 30. The measure of angle C, they tell us is 75. Equals 180. So let's add these together. And if I'm writing the measure of angle A over and over again. If you're one of those people, you want to replace that with an X, feel free. 30 and 75 is 105. And then subtract the 105. So the measure of angle A is 75. So the measure of angle D had better be the same. So the measure of angle D is 75 degrees as well. Right? Because we know angle A and angle D are corresponding parts of congruent triangles. So they must be the same as well. Give this a try. See if you can do it. Again, maybe draw a picture. Okay, so let's go ahead and talk this through. Once again, you know, it's basically the same problem, right? Draw yourself a picture first. Maybe make it better than mine, but you know, you do what you can. WYS, I'm going to do the exact same thing as I did last time. MKV, again, I'm going to do the exact same thing as last time. And let me just, you know, let me label now. So W is 62, Y is 35. And I want to find angle V over here. Well, angle V over here corresponds to angle S, right? So if I can find angle S, that's going to be the exact same thing as angle V, and that's all you have to do. So let's do that. These three should add up to 180, and once I find what X is, it'll be my answer for angle V. So 62 plus 35 plus X, the three angles of a triangle equal 180. So let me combine my like terms. All right, and let me subtract 97. You know, you do that out and you better get 83. So angle S is 83, right? So angle V and the measure of angle S, right? So the measure of angle V also is 83 because these are corresponding parts of congruent figures, and we know that corresponding parts of congruent figures are also congruent, right? Okay. Third angles theorem. So this right here is sort of a little extra little bit of information. One might, if we were using much higher level vocab, we would refer to this as a corollary. We'll use that word later on, I'm sure, but this is what's called a corollary. If we know that something is true, then this following statement follows from our facts. So the third angles theorem basically says if you know that you've already got two pairs of angles in a triangle that are congruent, the third pair of angles also must be congruent whether you have it already or not. So we know, and here's how we show this. We know that angle A and angle D are the same, angle B and angle E are the same, angle C and angle F are the same. Well, we don't know C and F yet, right? That's what we're trying to find. But we know A and D are the same and B and E are the same. We also know that the three angles of a triangle add up to 180. So I'm going to just sort of, this is not going to be like a really, Like, I'm not gonna do a nice big rigorous proof for this one. But, we're gonna follow the exact same process that we had done 50,000 times already. They're both equal to 180, so they're both equal to each other. We already know that A and D are the same. We're gonna be able to subtract those out. We already know that B and E are the same, so we're gonna be able to subtract those out. And so all this here goes to show that the measure of angle C is the same as the measure of angle F, which means that these two angles must be congruent. So think of this, the way that I always describe it to people: buy two, get one free. Right? If you know you've got two pairs of angles on a triangle that are the same, the third pair obviously has to be the same, right? If this is 50 and this is 50 and this is 70 and this is 70, well, then this is going to be left over as 60. This is going to be left over as 60. They're going to be the same, right? Buy two, get one free. If you've got two that are congruent already, then you get the third pair for free.